All right, so we'll take the first term, so 4p in this case, and we're going to distribute over. And remember, when we're multiplying variables together, we add the exponents. Okay, like variables, add exponents. All right, so 4 times 2 is going to get us 8, and then p times p is p squared. So it's 8p squared. All right, and then 4p times positive 8, that's going to be plus 32p. All right, and then if you want to use colors, if you get confused with, where you are in the problem, then just change colors, and now we're going to take 6 and distribute that over. So 6 times 2p is 12p, so plus 12p. And then 6 times 8 is plus 48. Okay. Also, if you're, really not sure on, some of the multiplication, definitely use a calculator. All right, now we can combine like terms. And we're going to make sure our final answer is in standard form. So the highest exponent is 8p squared. That's going to go first. We can add the 32p and the 12p together because they're like terms. So that's going to get us 44p plus 44p. Don't add the exponents. All right, and then plus 48 at the end. We're in standard form. We can see that this is a degree 2 polynomial. Leading coefficient 8. Just again, some review concepts from yesterday. All right, number 10, same thing. So we'll take 6n this time and distribute that over. So 6n times 5n is 30n squared. And then 6 times negative 4, 6n is negative 24n. And we'll distribute the negative 4 over. So minus 20n plus 16. All right, so we'll combine like terms. Put in descending order. So 30n squared minus 44n plus 16. All right, so go ahead and do 11 and 12. Okay, so same thing. All right, so now we're going to move on to a 2-term polynomial times a 3-term polynomial. Okay, so a binomial times a trinomial. So when we multiply 2 times 3, we're going to get 6. So we're going to get 6 terms, and And then if you can combine like terms, then you will. You'll get it down smaller than 6 terms. But when you initially multiply 2 terms times 3 terms, you're going to end up with 6 terms. Just like here, when we multiplied 2 times 2, we got initially 4 terms. But then we were able to get it down to a smaller number by combining 2 terms instead of 3 terms. So that's the idea, is make sure that once you distribute, okay, we're going to take this first term and distribute it to 3 terms, and take the 5 and distribute it to 3 terms. Okay, we should get 6 terms here. Then we can combine the terms. All right, so taking the 2p and distributing that over. So that's 8p to the third. Okay, because p times p squared is p to the third, because you have to add exponents when you're multiplying. So multiply the coefficients, add the exponents. All right, 2p times p is 2p squared, so plus 2p squared. 2p times negative 1 is minus 2p. Now let's take the 5 and we'll distribute that over. So 20p squared plus 5p minus 5. Right, so there's our 6 terms. Now we just want to try to combine like terms. Again, we want to put our final answer in descending order. So 8p cubed is going to go first. We have a 2p squared and a 20p squared. We can combine those. That's 22p squared. A negative 2p and a 5p, that's plus 3p. And then a minus 5 at the end. So we got it down from 6 terms to 4 terms. This is a degree 3 polynomial, leading coefficient 8. So go ahead and try 14. All right, so again, a lot of this is just keeping track of where you are in the problem, what you've multiplied together, what you still need to multiply. So that's why if you maybe use 2 different colors, things will stand out a little bit more. You can see with the red here, that tells me I distributed 2 over, 2n over, and then with the blue, it tells me I distributed negative 1 over. All right, so now we're going to do a 3 term times a 3 term. Right, so 3 times 3 is going to get us 9. We're going to get 9 terms initially, and then we'll be able to simplify. We're only going to do one of these, so we'll just do 15. You can cross 16 out, because I know these problems are going to be really long. So this one right here is going to, 9 terms is going to take us, all the way over, probably over here on this. So if you do one of them, then you should be able to do all of them. All right, so we're going to start with 8n to the 4th. All right, so there's our 9 terms. So first, make sure that you've gotten the 9 terms correct. That's just distributing each of those over. And now we'll go ahead and start combining like terms together. All right, so negative 4 minus 10 is negative 14. Negative 14 minus 16 is negative 30. All right, negative 5n and 16n is plus 11n, and then plus 8. All right, so let's go ahead and turn it over. All right, now we're going to look at what are called special products. So when we multiply these out, there are shortcuts that you can use if you can see it. If not, it's okay. Just do it the exact same way. So on 17, when we're multiplying these two binomials together, what we can recognize is they're exactly the same, except they just have opposite signs. One's a minus, one's a plus. And so something special is going to happen when that happens. Okay, so you have the exact same terms, just opposite signs. So let's go ahead and we'll take that 6p again and we'll distribute just like we did before. All right, so 36p squared plus 24p. All right, and then we'll take the negative 4 and distribute that over. So now when we combine like terms, we can see that we have the exact same terms in the middle with just opposite signs, and they're going to end up canceling out. So then we have just 36p squared minus 60. All right, so that's what's going to happen when you have opposite signs, but the exact same terms in both polynomials. So I want you to look at it and go, oh, wait, something different. I couldn't combine those together. Well, you're not supposed to because they're supposed to cancel out. All right, so 18, same thing. Okay, you can see exactly the same terms, just opposite signs. So 9x squared minus 18x. Now we're going to get a plus 18x minus 36. So again, we can see in the middle they're going to cancel out. All right, so go ahead and try 19. So you can see exactly the same terms in both, just opposite signs. All right, and then the last three, this is called squaring a binomial. Right? So when you have a binomial, two terms inside, so there's addition or subtraction inside with a square on the outside, you're not allowed to just bring the exponent inside. Right? That's big no, 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 no. Can't do that. Okay? If it's all multiplication inside, then you can. So if it just said AR, 8AB, 8AB squared, any of that stuff, that's all multiplication inside, then you're allowed to bring the exponent inside. But when it's two terms or more, you can't do that. You have to write it out twice, because that's what a square means. It means to rewrite it and multiply it by itself. Okay, we're multiplying 8r minus 3 by itself. So you want to write it out twice, and then you just do it like before. So this is the key on this kind of a problem, is to double it up, and then just distribute. Now there is a shortcut you'll see what makes this special. And some of you may recognize it from Algebra 1. But if you don't, not trying to make you memorize anything, just continue to distribute over and combine like terms. So when you write it twice or double it up, what happens is the middle terms keep repeating. Okay? So they're not going to cancel out. They're going to be the exact same terms until you'll be able to combine those together. Okay? So it's just multiplying it by 2 or adding them together. All right, so you get 64r squared minus 48r plus 9. So the trick on this is, if you see it, okay, if you square this first term, you get this first term. If you square this last term, you get the last term. If you multiply these two together and double it, you get another term. Okay, so that's what makes it special. If you can memorize that pattern, go for it. If not, just do it exactly the same way as we did. That's the safest one. Great. Question?